Let's now discuss this question. A train starts from rest and accelerates uniformly at the rate of 2 meters per second square for 10 seconds. Okay. Means initial velocity of the train is 0. Accelerates uniformly at the rate of 2 meters per second square. Means A equals to 2 meters per second square for 10 seconds. So first of all, write all the information. T equals to 10 seconds. It then maintains a constant speed for 200 seconds. So this is case 2. When it has maintained the constant speed of speed means velocity for motion in one dimension. When direction is not changing, we call it velocity. 200 seconds. It maintains a constant speed for 200 seconds. Sorry, this is time. The speed is unknown. And it maintains a constant speed for 200 seconds. How will you find this velocity? As the question starting, it is given that it starts from rest, accelerate uniformly for 2 meters per second square for first 10 seconds. So it has increased the speed. It means that finally it reaches to a speed. So how to find that speed? We must think about that. Then there is one more case. The brakes are then applied. So this is the case number 3. When brakes are applied means it is retarded uniformly. It is given in the question that the train is uniformly retarded and comes to rest in 50 seconds. Means first it has traveled for first 200 seconds with the same speed which it has reached at the end of this 10 seconds. Then after 200 seconds, when its speed is equal to this V1. V1 means final velocity in case 1, which is the constant velocity in case 2, and which is the initial velocity in case 3. V1, which is the final velocity in case 1, remains constant for 200 seconds. So it is the constant velocity for 200 seconds. Then in case 3, when it has applied the brake, when the brakes are applied, initial velocity is equal to the final velocity in first case, and finally it comes to rest means final velocity in case 3 becomes 0. It is written that and comes to rest in 50 seconds, and it takes time of 50 seconds to come to rest. So we can solve it with graphs or without graphs also. So first of all, we will solve it without using the graphs. In first part, we have to find the maximum velocity reached. And in this, we already have discussed that the maximum velocity it has reached is V1. So how to find this? This we have to think first of all. So if we look at the first case, it is U, A, T, and V. It has 4 information. So if we think about the first equation of motion, which is V equals to U plus AT, so we are observing that it has all the 4. One is unknown, V. U is given, A is given, T is given. So out of 4 quantities from the first equation of motion, 3 are given and 1 we have to find. So we write from first equation of motion v equals to u plus at. We have to find and have assumed it to be v1. U, it starts from the absolute 0, plus a is given 2 into t is also given 10. 2 tens are 20 plus 0, 20 meter per second. And we already have discussed that this is the maximum speed. So maximum speed attained by the train is the same 20 meter per second. Then in second part, what we have to do? In second part, we have to find the retardation in the last 50 seconds. Means in this we have to think about the third case. In that we have to find retardation. Retardation means acceleration. So this is again v, u, a and t. So again we use the second equation of motion. In this we mention it that we are using case 1, and in second part retardation is asked in last 50 seconds, so we are using case 3. And again from first equation of motion v equals to u plus at. It implies v is 0 and u means initial velocity, which is equal to v1, plus a is unknown, time is 50 seconds. It implies 0 equals to v1. V1, value of v1 we already have calculated in first part, 20 plus 50. It implies we transfer this 50 to left hand side, it is equal to 20. It implies a equals to 20 upon minus 50. 0, 0 cancelled out, minus 2 by 5, so minus 0.4 meter per second square. So this is the retardation which we have to find in second part. Next is third part. The total distance traveled. So how to find the total distance traveled? Means we have to find the distances traveled by the train in all the three cases. For case 1, if we name it as S1, so S1 is unknown, and what are the quantities which are given? So we observe U is given, U is given, and A is given, and T is given. V is not given, but we have calculated, and we have to now find S. So if you think about the second equation of motion, now what is the second equation of motion? It is S equals to ut plus half at square. S is, we have to find u, initial velocity t, time a given t given. So we will use that equation of motion only, and we write from second equation of motion. S1 is the distance traveled in case 1, ut plus half at square, u is 0, time is 10 seconds plus half, acceleration is given 2 into time 10 square. 2 to cancel out, 0 plus 100, it is 100 meter. Okay. So displacement in first and second is 100 meter for case 2. For case 2, if we assume that displacement is st s2, and again we want to use the second equation of motion, but in this u means initial velocity is given. What is the initial velocity? It is equal to v1. And what is the final velocity? This is also equal to v1, as it is moving with the constant speed for 200 seconds. Look at this. Means there is no acceleration in this case. Acceleration is zero. Why? Acceleration is rate of change in velocity. No change in velocity means acceleration equals to zero. And if we use ut plus half at square again. Now u means initial velocity and which is equal to final velocity. We have discussed this in case 2 at this point, which is equal to v1. v1 means maximum velocity attained by the train into t plus half into acceleration is 0 into t square. Means it is only equal to v1 into t. So always remember, whenever there is constant velocity, we use displacement equals to velocity into time only. There is no need to show it by this method. This I have discussed for you all. Though you can do this also, but remember, for constant velocity, we take displacement equals to velocity into time. Always there is no acceleration. And it can be derived from the second equation of motion also. Now v1 is, we have calculated the value of v1 as is 20 meter per second and time is 200. So it is 4,000 meter in all. So this is displacement in next 200 seconds in case 2. And now we will find it for case 3 using the second equation of motion again. S3 equals to ut plus half at square. Now u means v1 this time. We already have written this in case 3. U equals to v1. Time is t plus half. Acceleration, there is no acceleration. We can represent it by a1 also. As a means acceleration in first part, so it can confuse. So write it as a1. a1 is the retardation into t square. So now when we find the displacement in third part, it is v1. v1 is 20 into t. t is for last 20 seconds, for last 50 seconds. Plus half into a is, a1 is retardation, which we have calculated in this part, is minus 0.4 meter per second square into t square is 50 square. 20 into 50, 1000 minus 1 by 2 into 0.4, 0.2 into 2500. So it is 1000 minus 500, that is 500 meter. So the total displacement is equal to S1 plus S2 plus S3. S1 means we have calculated it in the first part. It is 100 meter. S2 is 4000 meter. S3 is 500 meter. So add these three. S1 is 100 meter. S2 is 4000 meter. S3 is 500. So in all, it is 4600 meter. That is 4.6 kilometers. So try to write the answer in kilometer if it is greater than 1000. Though it doesn't affect the answer, you can leave it in meter form also. I think in your book it is given in meter only. Next thing which we have to find is what? Read the question again in fourth part. we have to find the average velocity of the train as it is moving with the different velocities. So average velocity equals to total displacement upon total time. Average velocity equals to total displacement upon total time. Now the total displacement we have calculated is 4,600 meter and total time in first 10 seconds, then 200 seconds and then 50 seconds. Na? You can look at the three cases. First time is 10 seconds, second time is 200, third time is 50. So it is 216 all. But don't write it directly 2000, 216 without calculating. 460 by 26. And if we change it to lowest term, 230 upon 13. 13 ones are 1300, 13 sevens are 91, 90, 13 six are 78, 120, 17.69. Or remember, we can leave it in mixed fraction also. 17 whole 9 by 13 meter per second could also be the answer. So I think it must be written 17.69 in your book. So what is the answer? You can tell. Here do you? In this question, if you speed is given in kilometer per hour, to change it to meter per second, you should multiply by 5 by 18. 18 5s are 90, 5 into 5, that is equal to 25 meter per second. And then brakes are applied. So retardation, that is negative acceleration will be there. It is brought to stop means final velocity becomes 0. And acceleration, retardation is also given. So retardation is minus 0.5 meter per second square. In place of retardation, we write A equals to minus 0.5 meter per second square. Okay. Find the velocity after 10 seconds. So we have to find the velocity after 10 seconds when initial velocity is given, A is given, V is given, T is given. So we can use first equation of motion. I am writing directly. You have to solve it with full presentation. So initially the velocity was 25. Okay. I'm taking it 0. 25 plus A is minus 0.5 and T is 10. So it is 25 minus 0.5 into 10 is 5. So it is equal to 20 meter per second. Okay. Then in second part, find the time taken by the train to come to rest. Means we have to find time when velocity final becomes 0 in case 2. And this is case 1. So in this again, U equals to 25 meter per second. V is already given. And we have to find the time and retardation is also given. So use V equals to U plus AT again. Final velocity is 0. Initial velocity is 25. Acceleration is minus 0.5 into T we have to find. So when we transfer this 0.5 T to left hand side, it is equal to 25. It implies T equals to 25 upon 0.5, that is 50 seconds. Is that clear to you now?